I don't want to give you a challenge like that. Okay, this is the fourth part of our screencast discussion of the sample midterm questions. So you guys, anything we write together on the board, anything I say, will be available online, and you can download the notes as well. We've covered almost all the other questions before we got to you guys. So we're starting here with these multiple choice questions that are for matching constant momentum bar charts. So the word description is given, and you're going to be given a selection of charts. You know, maybe a chart that looks like this. For example, if we just say this is the initial momentum of A, the initial momentum of B, the final momentum of A, the final momentum of B, could, as far as you can tell, could this chart match the situation where carts are moving as described? Take a minute. If you have any doubt, sketch what this describes. Good. That's excellent. A is moving right. Good. B is moving right at a slower speed. So here's a picture of our initial state.
B will move faster, but A will slow down. A can't go faster. Unless, of course, you're talking about it's only because they both have to be in the same direction. I'm assuming
now let's see.
It's only for you. The first part, we don't know any mass rate.
The masses could be different. They could stick together or not stick together. We don't have any information about what happens there.
Yep. That won't work. So the only reason it won't work is because the initial one is supposed to be the same way. Yes, that and because
so as you guys are saying,
you don't know that.
if the direction of the velocity is right for both of these, the direction of the momentum is going to be in this direction as well. So you can immediately eliminate this chart because the initial state does not match. This shows one momentum in the positive direction, one in the negative direction. They have to be the same. A chart that had an initial state like that could match. Or wait, could it?
Yeah.
Okay. It says A is moving faster than B. How about a chart with an initial part like this? Could that match?
Yes.
Oh, yeah.
Well, okay, then let me be more specific.
Yes, it can. Car A. It can. Yeah. That's momentum. What if like B is like 4 times as heavy?
Snap.
All these are momentum.
No.
Always momentum charts. We don't make velocity charts because velocity is not a quantity that's conserved. Both of these could totally be pictures of a situation where A is moving faster than B. This could be, and this could be. Well, cart A might have, since momentum is mass times velocity. Yeah, totally. A could have a big velocity but a tiny mass. And B could have a smaller velocity but an enormous mass. P. Not is velocity. What?
You have a less one because part B is moving out slower. Oh, no, wait, that's just momentum.
Yep. Good. Next slide. This chart shows a final state when 2 objects are both moving in opposite directions. This shouldn't be hard. How about a chart with a final state like that? No, because this is not moving and moving. Yeah. And this, of course, is no good. Same direction.
Can it be like the velocity? Okay, this is just
Yep. Listen, this is going to be a good question.
the velocity 5 and like mass V5, mass V5 V5 and the other. Yeah, that means that they're just going at the same objects. Yeah, but if they have like different velocities, but then like corresponding masses that are like the same as the other one of the velocities, would it come out to be the same?
Yeah, but it has to be different masses. One velocity would have to be like
Well, they could be going in the same direction. They could just be the full point this way. Car can go in the same direction. And then car A bumps into car A.
Let's. How about this? This chart could show a final state where two objects have equal mass and both moving at equal speeds. Well, what's the
What do you
difference?
mean by equal?
speed is not
Equal to each other.
No, do you mean like their velocity is the same, but the magnitude is the same?
It says equal mass
And equal speeds.
and moving, as in v does not equal 0 at equal speeds.
Does that know what the magnitude of it?
Yeah,
So it's speed
Yeah,
you still don't know what direction though.
which means it could be in any direction.
Could these match? Could these match? Okay.
Actually, yes, yeah.
No.
Is that, oh, is this momentum?
Yeah.
but it says equal mass.
If they have equal mass and
Okay. Okay. Same. They have the same mass. So there must be different. Therefore, these must be different speeds. Okay. Could match. A large truck and a small car collide head-on and both stop. Large truck, small car, stop, stop. Large truck, small car, stop, stop. Large truck, small car, stop, stop.
Would the first one have to not work? 'Cause it's not head on.
it's the
Third one could work.
Only 2 and 3.
Two wouldn't work.
Wait, this is
No,
the
two would.
momentum.
How would two
Only the
work?
last one.
Because they're opposite.
How is it a large truck and a
They still
small
wouldn't
car?
completely
They're
cancel
opposite.
out.
Yeah, it's the last one. They have to be
Maybe
equal.
then flip over.
Awesome. Very good. This does not work.
Because otherwise if one was more, it's like
Maybe the guy slams the truck slams on his brakes before the or it flips over.
Okay. Good. Good. Plus, this plus this does not equal this plus this. Now here, we have opposite directions. Opposite directions, check. We have both stopped. Check. Looking good so far. But the numbers don't add up.
Yeah, but they have different masses.
Yeah, but this isn't mass, this is momentum. So it's already got the. It doesn't say anything about velocity.
Okay, now here we have different directions, and they're both stopped, but hang on, one's supposed to be a large truck and the other a small car. How can they have equal momentum? Yes, same deal. Big M, little v, little m, big V. And these momentum quantities are not that unfamiliar. Let's see. If Chris and Gray both have hourly jobs, they both get paid by the hour for their part-time jobs, 2 different jobs. If they work the same time, let's see. let's edit this. Hang on. Never mind that for now. Checking a bar chart. Okay. Check your bar chart. Do the numbers add up? Okay. Total initial plus change equals final. You can rule that out right away. And then check, do the bars match reality? Okay, that means that in the online podcast, screencast, we've gone through each of the questions. So if you haven't seen each of the questions discussed in this podcast, in the screencast here, you can check it out. And remember, when you get to mophysics.com, get back there. You're going to see the questions. You're going to see a formula sheet. You're going to see, yeah, it'll be in the room. You're going to see a summary. Yeah, sure. You're going to see your lesson materials. It's going to be great.
I have a question.
Okay, end of part 4 recording.
Motto.
Yep.
Was the other one show? Like in the last question?